So good morning to everyone. MT8791 Embedded System Design, final year 7th semester Mechatronics, Regulation 2017. So Unit 5 Embedded Programming and Laboratory. So in this Embedded Programming and Laboratory, we are going to see about the topic IO programming, interrupts and timer applications, interfacing keypad and interfacing LCD, interfacing ADC and DAC. So in this first topic, we are going to see about the interfacing LCD with the ADC. So in this slide, we are having the interfacing LCD with the ADC block diagram. So in this unit, we are in this unit, it's a type of projects implementations. So with the PIC microcontroller, we are going to interface some components, and it will used for the real-time projects. So that's why they are including the 15 unit as laboratory. So in this laboratory, we are going to see about the first topic as interfacing LCD with the interfacing ADC. So in this analog input, we are having the charge and hold coupled to capacitors will give that is successive approximation register conversions which respect to digital 10-bit output. So this likewise we are having the control of all the devices and all the inputs, it will be converted into analog into digital converters. So it's the interfacing diagram. So we are going to see about one projects regarding this, how to interface the LCD with the keypad. So this is the interfacing LCD with the keypad with the PIC microcontrollers. So this is the interfacing diagram. So normally we are having the LCD as 16 pins, VCC, ground, R0, register select, read, write, data lines, and anode and a cathode. It's like all the interconnecting pins which is connected to the keypad. So in this interfacing keypad, we are having the 16x2 LCD, totally 32 characters we have to display. The next one is the place the data command in the D0 to D7, the LCD. If you are intended to write a command, you got make a register select pin on the LCD low, whereas the writing data you have to make the register select as well. So the enable one, it's a specific delay. The read write pin should be remain as logic as 0. So the OF, this LCD commands, the OF stands for the LCD on and cursor on and cursor blinking. The 01 clear screen, 2 return home, the home, 4 decrement cursor, 06 incremental cursor. E stands for the display on and cursor on. 80 will be stands for the force cursor on the beginning of first line. CO stands for the force cursor on the beginning and second line. So 38 stands for the use 2 lines and 5x7 matrix. 83 stands for the cursor position and cursor line and position 3. 3C stands for the activating the second line. 0C3 jumped the second line position 3. 0C1 jumped the second line position 1. So these are the 4x3 keypad structures. So 4x3 keypad structures, we are having the uses of 4 rows and 4 columns. It's have a keypad for scan for any inputs, and was done means by the method of polling. So the scanning takes place keeping a specific rows low at a time and read at the status of the column pins as the input at the instance. So these are the code. So code having, we have columns and rows and the LCD pin which is interface to that keypad. So if you're giving some inputs to the keypad, in the sense the message will be displayed in the particular LCD. So likewise we are having the program in the rows and column combination. So in this rows and columns combination, if we press that key, in the sense it will be displayed in the LCD. So likewise we are having the code comprises of 2 subroutines. The first one is LCD message and the for awaiting data commands to the where keypad, it's to scan the keypad. So in the LCD message function, the command data values has passed to the functions while calling the character B is and the RS value by using the int C. 0 implies the command at 1 for the data. So in this class we have seen the LCD interface to the ADC. In the next class we are going to see about the LCD with the DAC. Thank you.